says find S. So S is my question mark. Here is a copy of the formula sheet I'm giving you. Please don't write on my copies. I don't want to have to run new ones before every test from here until the end of the year. And so there's a lot of formulas on here. Obviously, we're not using all of them. The formulas you're looking at are just the top left, the application formulas. Those are the 5 that we've been given so far. If R equals 5 feet, T equals 1 minute, and omega equals 15 radians per second. Do you notice any issues here to begin with? This is minutes and this is seconds. If we are going to use these in a formula, they have to have the same units. So we have to change one of them. It doesn't matter which. What would probably be the easiest? 1 minute is the same as 60 seconds. So I'm going to use that. So then, if I need S, look at your formula sheet. Your options are S equals R theta. We have R, but we do not have theta. Or V equals S over T. We have T, but we don't have V. So this will have to use a combination of formulas. Which one do you want to go with? F. Okay. So, yeah, if you want to use S equals R theta, we need to find theta, so you can use the omega equals theta over T to get that. If you had chosen to use the V equals S over T, then you would have to use V equals R omega to first get V. So please write what formula you're using because there are different ways to do the problem. So if I use this, my omega is 15 radians per second equals theta over T. We said we have to use the 60 seconds, so my units match. So multiply over the 60 seconds. Seconds would drop. So 15 times 60 is You didn't do it that way? Okay. 900. And that is in radians. Okay. So now we can do S equals R theta. So S is R, which is 5B, times my theta, which was 900 radians. So when you multiply those, you get 4,500 feet. And you should have gotten the same answer if you did it the other way. Questions? So that one involved a conversion as well as using a couple different formulas. So you guys could handle one like that if you had to? Let's look at number 5 as well. I told you that was probably the hardest one on the review, so let's try that one. Tells us that a lawnmower has a blade that extends out 1 foot from its center. What does that represent? The tip of the blade is traveling at the speed of sound, which is 1,100 feet per second. So you have this blade, and I'm talking about how fast the tip is traveling. So what is that? S is the distance it travels. If I give you the speed it travels, that is V. Or you could look at the units. It's feet per second. If it's a something per something, it's V, either V or omega. Feet is linear, so that's our V. So V is 1,100 feet per second. And I want how many revolutions per minute, so something per something. So we're looking for omega. So we can do V equals R omega. 1,100 feet per second. omega. Divide by your 1 foot, and the feet cancel, so it's 1,100 radians per second. We know if we're using omega in a problem, it has to be in radians, but I asked you something a little bit different in this question. I asked how many revolutions per minute. So what do we have to do now? Convert it. We have radians, I want revolutions. So I need radians to cancel, so it goes on the bottom, revolutions on top. 1 revolution is all the way around the circle, which is 2 pi radians. All right, and then we have seconds. We need minutes, so we need to put seconds on top, minutes on the bottom. 60 seconds in 1 minute. So then you multiply with 33,000 over pi, or you could divide those revolutions per minute. So that's just another problem where we have to practice that conversion. Is that one okay? Let's practice a couple of the unit circle type questions I might ask you. So I've told you I'm not going to require you to fill out a unit circle, but if it helps you, I have blank ones. So if you're in the middle of the quiz and you're like, oh wait, I need to see a unit circle, or I need a blank table, we used to fill out the tables, I have copies. You can have them at any time if you need to fill out one. So if I asked you to find the cosine of 7 pi over 6, what 2 pieces of information do I want you to write down? Seven pi over 6 is what quadrant? Third. Reference angle in radians, you just ignore the number on top, so that's pi over 6, or we know pi over 6 is like 30 degrees. Okay, in quadrant 3, is cosine positive or negative? And then cosine of 30? If you filled out a unit circle, what would you be looking at for cosine? The x. On those ordered pairs, cosine is your x. If I asked you for cotangent of, let's do 7 pi over 4. What quadrant is 7 pi over 4 in? Reference angle is, pi over 4, which is 45 degrees. So in quadrant 4, is cotangent positive or negative? Tangent of 45 is radical 2 over radical 2, which is 1. So cotangent would be the reciprocal of 1, which is 1. So negative 1 is our answer. What if I said cosecant of negative 2 pi over 3? What do we do if I give you a negative angle? So negative 2 over 3 plus 2. Or 2 is like 6 pi over 3. So negative 2 plus 6 would be 4 pi over 3. What quadrant is that? Third. Reference angle is pi over 3, which is 60 degrees. Okay, in quadrant 3 is cosecant. That's a reciprocal of sine, so positive or negative. Right. Sine of 60 is radical 3 over 2, so cosecant would be the reciprocal of that, so 2 radical 3 over 3. So those are the same types of questions we've had before. We just had them in degrees on the last test. Now I will ask it in radians. Are those okay? Last one. What if I said, find S in this interval so that tangent of S is equal to negative radical 3. So I'm asking you to really work these problems in reverse. If you are between pi over 2 and pi. What quadrant is that? Okay, reference angle. When is tangent radical 3? 60 degrees, which in radians is pi over 3. So in quadrant 2, what's pi over 3? 2 pi over 3, because in quadrant 2 the numerator is 1 less. Is that okay with everybody? Yes. Let's say I asked you for everything between 0 and 2 pi, where sine of s is equal to negative radical 2 over 2. When I say 0 to 2 pi, that's talking about every quadrant. But sine is negative. And what quadrants is sine negative? So we will have one answer for quadrant 3 and one answer for quadrant 4. Reference angle. When is sine radical 2 over 2? 45 degrees, which in radians is pi over 4. So in quadrant 3, the top is 1 more, so that would be 5 pi over 4. In quadrant 4, what's the pattern? Double minus 1, so that would be 7